Okay, so again, we're starting with that original landform. If you ever want to adjust that, you have these indicators to help with that. So like all these other ones, I have used the surface subdivide tool or the ISO trim to allow for that to happen. So let's turn this one off. And again, we have a nice division of cells that we're going to do a little bit more intricately. So we've seen how we can extrude these curves for pavers. We've seen how we can waffle them to make planters. Now we're going to show how you can perforate these to allow for water infiltration, and added quite a bit of kind of dynamics to them so that they change their characteristic quite a bit towards the end. So we have our subsurface divided. The first thing I did, because of the complexity of this, there's a lot of just filtering of data to clean it up, because the geometry is going to get pretty complex. And if you can see like around the extents of these that there's some really kind of wonky geometry, we're using this first part to just kind of remove some of that information. So the way I did it was just said, you know what, look at all these subsurfaces, find the area of them, and if their cell is too large or if it's smaller than 16 square feet, just ignore it. It's too small to manipulate. So that's what this is doing. I wouldn't adjust this one, even though it's a slider. Let's turn this one off, and let's just look at these two surfaces that are being outputted. So again, nothing really changes. You can see by looking at this B value, these are the surfaces that we're going to ignore. You can see that there's this kind of slither that's happening up here, and then there's these corner pieces that are also fairly small, as well as around this perimeter. Those cells are just too small to give us a quality output, so that's why we're just gonna ignore those, but manipulate all the rest that are shown here. So let's turn that one off. And similar to the paver script, we're going to, again, evaluate the slope of our surface, and you use the slope conditions to dictate how our surface gets perforated. So I'm going to start from this smaller component and drag all the way back and enable the rest. So again, we're kind of filtering that data. What this smaller component is saying is that if the surface has a slope condition that's smaller than or equal to 32%, to ignore it, and let's just use the larger ones. So anything that exceeds 32% is going, no, sorry, it's everything that's less than 32% or equal to is what we're going to perforate. So these series of dispatch components is again using this true or false logic to determine if it's within that 32% parameter. So I'll go ahead and turn on all of this. We can probably, let's keep scrolling. Let's move these ones over and this one over. So we're left with these three graph mappers, this offset component, and these two up here. Let's go ahead and just turn on or enable everything starting from there, that offset one and previous, and enable that. So again, we can go up to this very top dispatch component and turn that on to show, okay, these are again the pavers we aren't going to mess with. These are gonna stay as is. If I ever want to adjust that, I can change my slope percentage. So if I decrease that, that means we're gonna affect more and not affect less. If we want to affect things that are pretty much 45% and greater, that's how we change that. So I'm gonna bring it back to 32 though. So this is again another slider that you can play around with. So let's label this one and call it slope parameter. And so these are the ones we aren't going to mess with, meaning these ones that go from that same dispatch for a surface to curve logic, these are the ones we're going to affect. So it's not a whole lot, but again, if you change your slope parameter, you can affect more. So let's turn that off. And what's happening up above this or after that is that we're just finding the curve of those cells. They get very kind of crazy and complex in some of these areas. So we wanted to use this curve divide component and P-line component to just clean them up a little. You can see that it kind of loses some of those round edges, but that's fine because of the manipulation that we're going to do. It's really not going to be that relevant. So we'll turn that off. So now we're just left with this kind of more rigid cell. What happens now is that we're going to use, again, this logic. This one is controlled by the slope percentage. So depending on the slope percentage, we're going to offset these curves to start to create a boundary to them. So let's turn on this offset loose component. And now you can see that some of these cells have a larger offset than these other ones that are a little bit thinner. We can, again, change this graph mapper to change the offset. So we'll do offset size or offset distance. And we want it to go in the negative direction because we want that offset to go to the inside of these cells. And obviously, again, this is something you can adjust. So if you want it to barely offset, you can increase this graph mapper to be all the way to the top. If you want it to shrink a little, if you want there to be a greater adjustment or not, you can play with this graph mapper to achieve that. We don't want it to offset too far, so that's why I've limited it to negative 1.25 feet. Obviously, if you double click this, you can increase that 1.25 value. But again, it's going to get pretty crazy. Like these really start to offset quite a bit. We can always adjust them with this bottom slider. But anyways, I'll bring this back to -1. So we have our offset distance. The other part that we're going to do is we're going to use that same logic for the slope percentage, but now we're going to use that slope percentage to fillet these offsets. So instead of them having a hard edge, now they can be rounded or curved. So after that offset loose component, we have our fillet or the fillet component that I like to call it because it sounds like you're filleting a fish or something sharp. Let's go ahead and enable that one. We can turn off this offset component and turn this one back on. And now you'll see that, you know, these ones that are still kind of near the top have a sharp edge, But as we get closer, now they start to get filleted to have this kind of rounded opening to kind of diversify those perforations. So we go from having a very sharp hard edge to start to slowly have this kind of rounded opening, which is kind of cool. And then the last thing we want to do with these curves is to offset their distance. So instead of having these offsetted curves flush with the original curve, we're actually going to sink those down based off of the angle as well. So the ones that have the least or the slope percentage closest to 32% are going to more or less stay flush. But as they get steeper, that offset curve is going to get pushed into the landscape a little bit more. So that's what this graph mapper is doing, this bottom one. So I'm going to copy this one and change. So this is the fillet radius or fillet. So again, we can always, if you want it to be more round or less, you can adjust it from here. So if you want it to be more rigid, you can drag this point down. You can start to see how that affects those corners. So 10 might have been excessive as my max value. But anyways, there we go. So now we have our rounded ones. And like I said, this next one is changing how much these curves are going to get moved into the landform. So if I kind of follow this last graph mapper up to the amplitude, you'll see there's these three components, the amp, reverse direction. So instead of it going extruding up, you can have it extruding down. And this is that we're simply moving that fillet curve. So I'm going to turn this one off. I'm going to enable these and turn them on. So now you'll see that they're actually being moved inward based off of that same kind of parameter. These ones are pretty much staying nice and flush, but these ones that are getting really steep start to really sink in. And then the last thing we're going to do is we're going to, again, we use these flattened components to organize our data, to put them all in the same data tree. We graph them, and then we loft, and we'll see the magic of it all. So we're basically lofting that initial curve with that extruded curve to get this cool perforation in our surface.